Good afternoon. I'm Israel Ronn, President and founder of Spotem, and here with me today is Stephen Mellor, CTO of the Industrial IoT Consortium, and we are going to talk about IoT security. So, good afternoon to you, Stephen.
Good afternoon, Israel. How are you today?
I'm fine, and you?
I'm cold.
Okay, so let's start. You're the CTO of the IoT Consortium, so maybe we'll start with you telling us about the consortium involvement and the activities regarding IoT security.
Certainly. The Industrial Internet Consortium was founded in March 2014, which is about 27 months now, by 5 global companies, AT&T, Cisco, IBM, Intel, GE, did I miss one? AT&T, Intel, Cisco, IBM, GE. No, I got the lot. That's good. I usually miss one. And these global companies were concerned that they were constantly trying to find ways to work with each other on different projects, which of course is a great thing. But what was happening is that they were solving the same technical problems over and over. And they were similarly solving the same business problems over and over, making contracts, agreements, and so on and so forth. So they thought that there would be more value in getting together to coordinate activities and grow the market. This is actually a well understood concept, the concept of a so-called blue ocean market, which is so wide and so deep that there's no point in squabbling over tidbits over the shore, but rather the goal is to collaborate. Of course, there will always be competition, but to collaborate so as to grow that market.
What does the consortium is doing regarding IoT security?
Okay. Well, the consortium is actually working in 4 areas, so let me briefly describe the 3 and then I can go into security. The overarching construction is, of course, an ecosystem. The fact that we have people working together to find common solutions, to find partnerships, to find ways in which they can solve problems and make some money together, again, growing the market. That's one major element of what it is that we do. The second part, which I think is very important and perhaps almost unique, is the notion of a test bed. And a test bed is a controlled experimentation platform that allows you to try out new technology, or new technology being used in different ways, or to try out different business models, finding ways in which we can monetize data. There's a lot of data today that's being gathered from the physical world, and we're not really quite sure what to do with it, to be honest. So we're trying to work out some ways in which we can think about that. And that feeds into the third of the 4 main areas, and that is so-called business strategy and solutions lifecycle. This is a group that is focused on trying to understand, first of all, how you think about a project and understand the risks. This is particularly important because when we bring information technology and operations technology together, the operational technology is used actually in the factory or in the hospital. There are completely different sets of concerns and ideas that you need to think about. And it's hard to find people that know all the things they need to know. And even worse, it's hard to find people that understand the areas that they don't know. So there's a lot of work there to try and characterize projects, try and understand what you're getting from them. And then there is an effort then to understand how the implementation is carried out. So those 3 things feed the 4th area, which is technology. And technology has several parts. And for a long time, seeing as how I'm Chief Technical Officer, I had the idea that all this technology should be one thing. And our steering committee said, no, we need to have people doing technology things, and we need to have security people looking at it in a completely different way. So we need to get two sets of pairs of eyes looking at the problem, and at the same time we need to ensure that they work together. We don't want to just have architecture and then bolt security on afterwards. We have to be sure that they fit together. So last year we published an industrial internet reference architecture document that laid out the big picture, including, of course, security and a number of other themes such as connectivity, data management, the list goes on. And of course, one of those was security. And then each one of those areas is now going into much more detail. And the security working group is just about reaching the point that they will send out their industrial internet security framework out for review to our liaisons. That's already done, actually. And then the final version to our members. Now, what this document covers, as I said, it has to be related strongly to the reference architecture. It takes a look at what the problem is. Of course, you always have to start with a statement of what you're trying to solve. And then it looks at what is called the business viewpoint, which is what is it that businesses need to know and need to understand about security and how it's going to affect the systems and the equipment that they have out there in the field. I think very little, let me rephrase that slightly. I don't think enough emphasis is generally placed on this particular issue. I see lots of conferences talking about this technology and that technology, but what I don't see is what I don't see is a lot of people talking about these are the risks, these are the threats, these are the attack vectors, this is what your attack surface looks like, except in technical terms. I think it's very important that we bring it forward to the owners and the operators of companies, to systems integrators, and of course to equipment manufacturers, that security has to be considered at every step. So going now into a bit more detail, the next level, there's more, of course, there's always more. But the functional and implementation viewpoint then lays out some of the things that you need to consider in respect to making your system secure. Now, this involves an awful lot of technology. I'm not the absolute expert in that, I must tell you right away. So there's all sorts of acronyms in there. But the basic picture is pretty clear, I think. We have a reference architecture that allows us to think in terms of a stack of both information and operational technology ideas. At the bottom, of course, are assets, sensors, actuators, and so on. Above that, control, and then data management, and control management, and distributed control, until you get up to the application. But security looks at it in a rather different way. Security tends to think in terms of, I have to secure the endpoints, which is the name given for those parts of the system that are actually talking to the physical world. It also includes some communications devices, but basically it's the stuff that you're controlling and getting information from. You need to control communication, so you need to understand and make secure all of the communications that go from the edge through the fog, the mist, the haze, whatever, up to the cloud. And then you need to have a way of actually thinking about how you're going to secure the data, typically in the cloud, of course, but more generally at rest, in use, and in motion. So the reference architecture takes a kind of stack of ideas point of view, and the security framework looks at it on its side and says, okay, now you have to consider, as you gather data from an endpoint, how you're going to secure that, how you're going to secure it as it goes through all these processes, and then how you're going to secure it when you actually have data that you can use and turn into information and make sense of. So that's the basic plan of that, and we hope desperately, actually, to see this document published by our next quarterly meeting, which will be in September. But of course, we have to ensure that we have membership-wide consensus. Just signed some paperwork to send out the document to some academics, etc., etc., etc. That's broadly what we do and how the security part fits in.
That's impressive and something to expect. Maybe let's go and dive a little bit into security issues. Can you elaborate a little bit in your perspective? What are the main threats that are unique maybe to IoT or IIoT?
Mm-hmm. Well, of course, we don't know. The threats in IIoT, you can't say, well, the next thing that's going to happen is that someone will hack a dam or an electric plant, or they will come in through the radio and entertainment system in your car, which happened recently, by the way. We don't know. And if we did know, of course, we would plug those gaps. What we can say is two separate kinds of things. The first is that threat is serious, not scaremongering here, but the fact is that if someone hacks your credit card, that is a royal pain. But if somebody hacks your nuclear power plant, well, that's a rather different matter. And similarly, your chemical plant and your electricity and utilities and so on and so forth. So the potential downside is much greater. So that's the first thing that we have to understand. And as I said a little while ago, I think it's extremely important that that is made clear to the business people, because the business people need to understand that side of things so that they can take it seriously from project inception all the way through decommissioning. And of course, when they look at a existing control system or existing manufacturing plant and say, wouldn't it be nice to connect to the internet? They sit back and they understand, hang on a minute, we have to be very careful. So that's the first kind of business side of it. The more technical side of it is that the information technology and the operational technology people have different perspectives. And those perspectives have to be reconciled. So let's say, let's say that I'm building a plant with some chemical plant with some dangerous chemicals. Now, it might be, or maybe even military chemicals, it might be that we have discovered an IT security flaw, and the reasonable thing to do is to bring in some young fellow who's had a criminal record for hacking in the past, but who knows his stuff. Now, the trouble is, if this is a military installation, you're going to have a heck of a time getting that past the people, the security people that run these things. The MI5 is the Ministry of State Security. I don't know what it's called in Israel, actually. I should know. But in any event, they're going to have a very different perspective from the people that do IT. So generalizing this, five areas we looked at to create a so-called trustworthy system. One of them is security, in the sense that we IT people think about it. Another is safety. Another is privacy. We need also to consider resilience and reliability. Now, the point is, of course, that the people involved in constructing systems of this nature have completely different perspectives. So just to take a rather trite example, from the point of view of safety, you might want to leave a door open so that people can get out of a burning room. From the point of view of security, you want it locked. So a very simple example, but there's all sorts of ways in which these different properties, we call them key system characteristics, how they relate one to another. And you can't just pick one and say, well, that's the right way. And that speaks then to the next level of problem, which is culture. The people who are building manufacturing plants, electricity plants, and so on, have a very different culture from the people that are working in IT. If I'm going to build an electricity plant, it's going to be there for a minimum of 15 years. And if you make a mistake, you don't just upload a new version. Whereas the IT people think, well, we can do this, you can try that out, and if it fails, we can upload a fix, and no problem. And that culture clash is going to cause, and does cause, significant questions when you're trying to work out what it is you need to do. Just following that on one step forward, if I'm going to build a chemical plant, whatever, I have to go through a whole series of regulatory compliance steps so that I can demonstrate that this plant is safe and won't harm the environment and this and that and the other. And I have to go through that for each of the components that I use and how I put them all together, and so on. For the typical IT guy, well, you run it and see. Again, two completely different cultures. So we can't know, in my opinion anyway, in advance what the threats are going to be. What we can do is try and understand the different ways in which the threats can come at us. We look at that in those 5 different ways, and we try and reconcile them between the different areas. There are assessments that you can carry out. Actually, there are some that are essentially national or associated with verticals. For example, the electricity world, I believe, has its own capability, maturity assessment model, and so do other industries. So you can do that kind of thing, but you can't predict what the actual outcome is going to be. You can't say, well, this is where
maybe as the last question, let's go and look. IoT is not one single industry. It's an environment that is combined from many industries. Can you look at the IoT world in a vertical perspective and let us know what do you think, where are the most vulnerable areas in terms of security?
Mm-hmm. Well, I can, but from a technical point of view, perhaps not from a business point of view. I can come back to that a little bit later. But from a technical point of view, that's not necessarily a good idea. To give you one example, there is an organization which is called Industry 4.0. It's a German government initiative, and it is focused very heavily on manufacturing. Now, let's imagine that they have all of the technology that they've developed, and they build manufactured components, and then they want, let's say, a car. And then they want your car to talk to your smart home. How? Because those components, although they, of course, are manufactured as well, have a completely different way of looking at the world. The kinds of structures that you need in your smart home are not nearly as hierarchical, for example, as the set of components, the bill of materials for the manufactured component that you're constructing. And then similarly, your car is going to need to connect to the smart grid. Well, again, how? It's no good just saying, well, you plug it in. How are you going to transmit the data back and forth? How are you going to think about these different things? So there are multiple verticals. Manufacturing, of course, is one. Energy, transportation, smart home. Some people even include retail. All of these things. The main issue here is interoperability across.
Good. Okay, Stephen, thank you very much for enlightening us and giving us more perspective about the IoT consortium, your activities, and about your approach to security. And we are looking forward to see you and talk with you at the IoT Security Conference.
I hope so. Thank you. Thank you very much for your time. And indeed, I look forward to making that happen.